Alright, started. I'm just gonna go down the list. So I'm doing task async stuff, and I'm gonna show you how to use the await keyword. So in order to use the await keyword, you would just new up a task with using the factory preferably. It's like the worst thing you could do is to go ahead and do new task, because then you run into issues where your task has the potential to cause locks, I suppose, where you do something like this. Start. Between here and here is where the problem is. So it's better to use factory because this one handles all of the starting and newing up and what have you. So in order to use the await keyword, you have to have async on the method, otherwise it'll blow up. If you don't have async, then you can't use the wait. So this little thing that I wrote right here, it's just a little console. So I'll go ahead and run it. All it does is it starts a bunch of tasks and then finishes them whenever they're done. I numbered them so you can see that they're finishing out of order, which is what the task async await stuff does. If you don't have async await, these numbers would be in order from when you started it to when when it finished, and it would wait till one finishes before it does next one, the next one, next one, which would take a long time because this thing takes a long time to finish. Whereas with these, it goes really fast and goes through all of them in only a few seconds. So I sort of explained when you would use await async is when you have large tasks that you need to do, and it needs to be finished in a certain amount of time. Like, say I have to load a web page in under 3 seconds. I won't be able to do that if I have a ton of stuff on the page and I have to load it synchronously, one at a time, each element. The way to do that would be to use some await async to make it so your page loads a lot faster because everything's loading at the same time. So another piece that I'm going to cover is the Fubu stuff. So in Fubu MVC, there's actually a way to have async endpoints where you call the endpoint and it does the tasks like what the console is doing, where it has a task and then you return that stuff, and you can mix it with async and await for whatever you need to do. This way that you're not waiting on an AJAX call to finish before it does anything.
You realize you don't even need to do that inside of the start new, right?
Yep. But I just put it here just to show you that you can use configure await so it doesn't lock up the UI thread. So if you use configure await, the usefulness of it is so that you don't run into deadlocks when you're trying to hit the endpoint. Where if you were to straight up return this task and also do an await on it, it would cause a deadlock, probably. I didn't really test that part, but I do have a few examples that I can show you.
So one point here, though, that I just want to call out and why this is probably not a great example, that resp.result is a blocking call. And so you're kind of defeating the whole purpose of doing things async if you're going to do that, because you're tying up a thread to perform that asynchronous operation. and that thread can't do anything else, and that defeats the entire purpose of async. So
Actually, with this configure await, it doesn't block the UI thread.
that call to resp.result will not do anything until that result has come back inside of your start new.
Yeah, but the UI thread can continue to do other things.
No, it can't. Your call to resp.result is blocking.
So that task you're making is locking up a whole thread.
That's
just to wait on
equivalent
that
of
result.
that's equivalent of saying thread.sleep until the result comes back.
Another thing to note is that
Okay.
The UI thread would be for a Windows application, not for a web application.
It's not for a web application?
The UI is on the client side in a web application, not on the server side.
Well, that's true. Because the AJAX calls are async anyways. Getting back to the Fubu stuff, we will, so I showed you the Fubu MVC things with async and whatever. But now I'm going to show you the Fubu transportation things. So on the FT side, the handlers, whenever you send a message like bus.request, send whatever you need, Marco message, blah, blah, blah. You can actually, on your handler, you can have async and await. And it'll, based on my assumption, it'll make your messages handled in parallel instead of one at a time in the queue. There's not a lot of documentation on that aspect. I was asking around but didn't receive many replies, so I'm working on assumption in that regard. But this is how you'd configure Fubu transportation to use async and await.
What's your write to file doing here?
Write to file just writes whatever you had on your text.
Okay, so another suggestion I'd make is instead of wrapping that in a separate task where you're once again blocking, is to use the asynchronous IO APIs so that you're actually making it really async.
There we go. Now it is completely async because there's no file writing at all. So that is how you do the FT stuff. Another thing you can do with the FT on your endpoint side is instead of doing requests, you can actually do send and wait. This will actually cause FT to block until the message gets a response. Putting this in a task though is helpful if you want to Okay, putting in a task isn't that useful. If you want to block the response for the UI, you can just use send and wait, and anything after it will be run after it waits.
Do you want to just try just changing that around just a little bit? So you can kind of just show what you'd normally do with that.
How would you recommend that I change this around?
So change that to send and wait like you had.
Very well.
If you want to demonstrate that. Remove the task part, so those two lines are on where you're starting a new task. And instead of returning response.result, do await response.
Wait
I could just
response.
move your await call to to where you say RESP equals bus dot send and await, put the await in between the equals and the underscore.
Sorry,
Right here.
You can put it in front of.
Put the await right there.
we'll do that.
Await. Now you can take out the equals entirely because that's technically just a task without generic arguments. Now take that out, and it's just a regular task instead of a task.
Yeah, or you can, the
Or you
bus
just
dot
say-
request is the same thing, so if you change that to request, then there's a response you could get back and return, but you just have to await it.
Happy?
That'd be the more correct way to use that, so you're not actually spinning off separate tasks that are just gonna be blocking elsewhere.
The difference, Jack, is that in your first example, I think you were thinking in the terms of like a UI thread. You got to get off the UI thread and get into a background thread, and then but your background thread would have blocking operations in it. But this is more not blocking any thread. Utilizing TPL and the task library to not block any thread. You know, we don't need to get off on a background thread. We just need to get off this thread while we do a blocking operation and free up that thread for other service bus messages or web
Right.
threads. Or
Like if there's something you're doing that doesn't have an asynchronous API that doesn't return a task that's synchronous and is gonna block the UI thread, then you could definitely throw it off to a separate task so that your UI thread isn't blocked at that point. But if there is an asynchronous way to do it, where you can just wait, then you don't need to create a separate task.
and a lot of .NET libraries now offer task compliant APIs. You know, to make a web request to a third-party network, you know, web service or something, or file operations, or all these things that normally block threads. A lot of these have new endpoints that you can tie into and not block your own threads while using them.
I did notice that around when I was going around and trying to find information on this, I did notice that a lot of them were mentioning hitting external sources. Is one of the usages of tasks and asynchronous IT. And configure await didn't specifically have a whole lot on it. So that is why I probably was using it incorrectly. So let's move on to Raven things. Now, I couldn't get this Raven stuff to work in my project because every time I tried using the initialize on the document store, it would throw exceptions that were supposedly fixed in Raven, even though I set it up the way they said you should. So I am going to navigate to their page and demonstrate what they have on their page. So in my notes, I actually have this listed. You just initialize your document store like you would any other thing for Raven. But instead of doing open session, you do open async session. This will give you an async document store instead of a regular iDocument store. Then you can just call methods like load async or store, save. Any of these ones will provide you asynchronicity with Raven. So that way you're not waiting for it to store, save, and whatever, what have you, with Raven. So a few notes to take with you. There is a difference between async void and async task. Difference being async void handles errors differently than async task. Async void will a lot of times swallow an unhandled exception, whereas async task will throw it. But the caveat is async void is actually pretty useful when you are handling event handlers asynchronously. Whereas async task is useful in any other situation.
Do you know why you have to use async void for event handlers?
Because in event handlers, you're not usually returning things.
Right, it's the actual method signature for that event handler delegate requires it to be void.
Yeah.
To match that signature. So your async handler would have to be void just to be able to add it as an actual event handler.
In event handlers, I'm just going to repeat what you said into the mic. Event handlers are, the reason why async void is useful for event handlers is because event handlers, you don't normally return events because the delegate that you are implementing for the events requires a void return. Now, some of the pitfalls, best practices, I'll start with the pitfalls. The more tasks and asynchronous calls you have, like, well, for example, that blocking thread that I wrote, has the potential for you to put more load on the processor. Sometimes the tasks don't finish quite as fast as you think they would, and too many of them will start slowing down your processor because it has to handle all of them. Eventually, the more you have, the more synchronous it actually becomes, surprisingly. The more asynchronicity that you put into it. Because it is essentially handling it synchronously, it's just switching between them really fast. With more of the synchronous calls, you actually have a higher chance of running into concurrency exceptions when saving and loading stuff from the database or updating a property or a list object, which is bad, which is one of the pitfalls you should watch out for. Also, too much asynchronous work actually causes it to be harder to debug something when you have all these threads running. You don't know which thread is running what. So in that case, synchronous calls would be better. One of the best practices that I wrote down was to avoid async void whenever possible. Use async tasks so that you can handle the errors whatever way you want. And that just about covers it.
Can you go back to your that first example you had where you have the loops and the awaits?
Loops and awaits. This one?
Yeah. So which one were you running? Was it this first method or the start individually?
I was running this one up here.
Okay. So that would explain why they were actually executing or completing out of order. If you run that start individually one, they're actually still going to complete in order because the way it's written there, this is something to keep in mind as you're using awaits, is that it's not going to kick them all off. It's going to do it one at a time, and it's going to await for that one to finish before it continues through the loop to the next one. So await doesn't give you parallelism; it gives you asynchronicity. I guess that's the word. It is, but it's still sequential, that you can execute it asynchronously. So you would need to if you wanted to do something like this in parallel, you'd have to use something like task.winAll and await on that. So you can basically build up all your tasks for whatever you're going to do in parallel and await when they're all complete. Or the parallel library would help with that if you're actually looking for a collection. You can do a parallel.for each. It just kind of depends on your use case. Parallel would be blocking. So you want to be able to await that.
I'm glad you explained it because I was about to. That was actually the reason why I wrote that one.
Oh yeah.
Yeah, but I didn't. I guess I forgot to mention that one.
Okay.
Because I don't actually call this anywhere. I don't think.
Yeah, the first one there where you put the loop into the task instead. That way you could do it in parallel.
Mm-hmm.
Although what you'd want to do here is capture those two tasks and then do an await task.winAll on those two instead of awaiting the first and then awaiting the second.
I could do this,
Yeah.
Same thing on the.
but down here I would combine them.
Mm-hmm.
Whole task.
Or I could use this one.
Yeah,
Waits blocking them.
waitAll would be blocking.
In the
So the
console
thread's
though.
going to block for it, which means this method isn't really async. That's why it's grayed out up there.
I wonder if you can await on this.
That's why you have to say winAll. So winAll will create a new task for you that will complete when the task that it's waiting for completes. And then you can await that.
When I also noticed that in a few places they were actually doing a continue with. This wasn't exactly in the script stuff, but you can do a. So when this one finishes, this one will run. It's actually pretty useful.
That's very much like what await would do.
I was about to ask, are the task continuations pretty much abstracted away with the await keyword now?
Yeah.
Is that pretty much, they serve the same purpose, right?
Yeah.
They're not incompatible with each other, but yeah, they are.
Is there ever a reason you need to drop down to the task continuations and not use the await keyword?
I mean, there's always a case,
But
but
it's pretty rare.
I think you can achieve it. So really, anytime you see that await keyword, all that's doing is taking the results of after the await and
Look at that
pushing
monster.
it into a continue with it under the covers. It's just compiler magic that's doing it for you.
Yeah, if you guys, if you look at Stephen Tubbs' blog, he has quite a few posts about awaits and tasks and stuff, but he has a good explanation of the mechanics underneath it, how it works. When you call an asynchronous method, it executes all the code synchronously until it's in await. So even if it's in an async method, it's still going to run that code before it returns back to the caller until you get to an await. And then the rest of it just becomes a task. And then any other awaits are basically continuous that are added onto that task. And it'll just have more continuations from there.
You like this creation that I created? So here I'm using the task scheduler to actually run the synchronization context. And something I didn't mention about the configure await is if you do continue on captured context, it won't have to return to this specific thread to continue on the to continue onwards. So that's why I was mentioning the UI thread with the configure await, because if you have a UI thread and you are running this task on that UI thread, it has the potential to block it unless you do configure await, which will cause it to spawn up a new thread to use that to return to. And then it'll do the rest of your method.
The takeaway on configure await too is if you're writing any class libraries that other people are consuming, you can always use configure await false in every case, because otherwise you have the potential to introduce deadlock conditions on them if they're using it from a UI.
I didn't see that much around. Most of the time I saw don't trust the other person's API. It's like usually
it's
that
not
one.
about that. So like what happens if you're running a desktop application that has a UI thread? If there is anything in your call stack that is depending on something from the UI thread and they're both waiting on something, if it preserves the synchronization context, you'll end up getting yourself into a deadlock situation. Whereas most time in a class library, you're never actually going to need the UI. Team 4 last time that they actually had a demonstration they were able to produce that showed the deadlock happening, and it's really easy.
Yeah, the two others they had I guess had an example like that. I can't talk. So like if you're the reason you can fall into deadlocks is I've probably seen mentioned online that if you're using async, you should make it async all the way rather than mixing asynchronous and synchronous code. Because when you have any kind of synchronous code intermixed in there, that's where you can potentially run into a deadlock. Especially with the default behavior of await and it trying to return back to the same synchronization context that you're on. What would happen is, like, if your thread is blocking waiting for something because it's doing some synchronous code, whatever it was that was being awaited and executing off to the side, to try to come back and complete after the await and continue with whatever other code was going to execute on that original thread, but that thread's blocked and waiting for it, so now you're in a deadlock where the two threads are waiting for each other. So the configuration will just say, when this await completes and you continue on with your other stuff, you can go do it somewhere else. You don't have to come back to that original thread.
This will do a deadlock.
Yeah, like you've got that synchronous wait there rather than calling a wait.
Yeah. That was the example that I found when I was finding configure await info. In order to fix that, they actually went ahead and did task equals that.
I mean, ideally, whoever's using your code is just async all the way. But
Probably.
if you're coming into something that's existing and you're just trying to bring in async where you can, but you still have some synchronous code in there, then you might not always be able to make it fully async.
That's how you would fix the deadlock on the UI thread, assuming this came from a UI thread or is run with the UI thread.
Right.
With the configure await,
We actually did run into this ourselves.
so a lot of things I was running into with FT and there's async and it's async stuff was it was throwing invalid operation exceptions where it was trying to finish a task that it already finished. It has a few issues. I couldn't find much on how to fix that specific issue, which is why you saw inside of my remote handlers all of these try catches where Fubu exploded.
I haven't seen that.
It happens before it even like starts it. I'm not sure why.
Say that again. I didn't catch the first part.
Huh?
Say the first part of what you were just saying again.
Oh, Fubu explodes.
Why?
Why does it explode?
Explodes when you do the await on this task. I couldn't figure out why.
It's because you're not technically supposed to await tasks that are started. It's not really anything to do with Fubu.
You're not supposed to wait for a task that is not
You're
started.
supposed to use task.run, not task.start.
Oh,
start new was from the original task parallel library, but with async and await items.
Huh. Well, that might fix the issues. Well, I might as well run it since
What
you
does run
guys.
do that's different than?
You're basically indicating that you want this to run.
With-
just allow the scheduling to do
With
it.
run?
Yeah, it passes in some default options to start new. Spring has a ton of different options for this buying test out run. Just pick the defaults that work most of the time.
Which says go ahead and schedule this.
Yeah,
Is that-
and that way you don't have to type so much of it, having to go to the factory every time.
All it is a bunch of buttons that call those home endpoint methods.
So when somebody's learning TPL and async await and all that, is it easier or better to start with TPL without all the syntactic sugar of async await and then layer that on? I mean, that's the way I learned it because that was the way it was released. But
I would probably just go to
or is
the
it
C#
straight to
in-depth
async
book.
await?
I would just go to the C# in-depth book. And he explains it pretty thoroughly there.
Okay.
I mean, you can learn it in the old white papers even without thinking about async await, because you still have to really understand how tasks work in general to use async await effectively.
Right.
So yeah, I would try to understand tasks at a granular level before even throwing the keywords in there.
Yeah, I wonder if the async and await keywords and syntactic sugar was doing enough that you could just not worry about some of that TPL stuff anymore. Or if that's
Oh, hey, is the difference between start new and run? Is that run utilizes the thread pool?
They both utilize the thread pool. One's just not necessarily guaranteed to start immediately.
Right. Like this one's not guaranteed to start immediately, right?
And that one, the defaults there aren't quite the same as what run uses, and that's not quite the correct defaults that you should be using most of the time.
The default
start
where?
new defaults.
Yeah, versus the past run.
So
There's
run
there's tons of overloads starting for all the stuff you can set. So test.run just picks better defaults.
And just go to the definition.
I don't know what defaults you're talking about.
Go into
user sharp and go into it.
So there's tons of overloads, and I'm talking about the
What the
defaults.
heck? Where'd it go?
Or if you don't specify overloads.
Yeah, hang on. I don't know what I pressed. Okay.
Expand that.
There we go.
So you're reusing start new there with different.
Oh, it doesn't use the factory. And then where's start new, I wonder?
So back to your question, Mike. I think if you have a solid understanding of just what asynchronous code means and like what you have to think about, even if you are using the async and await stuff, you still need to understand the differences between asynchronous and asynchronous code and thread safety and the usual things that come into play when you have asynchronous code.
So you may not need to know the details of TPL because that's abstracted now, but you do need to know the concepts. Is that what you're saying?
Yeah, well, I mean, TPL is just one way to do asynchronous code. The other way is the old stuff with the begin and end methods to kick off asynchronous operations. All that stuff, async and await is just an easier way to do all that, so you don't have to manage all that yourself, but you still need to understand the implications behind writing asynchronous code. And like Jack said, if you have a ton of tasks and they're all modifying the same collection, if it's not thread safe, you're still going to run into all sorts of issues. So you still need to make sure code is thread safe if you're going to use it that way. You need to understand what that means.
But async and parallel are not the same thing.
Yeah.
Yeah, and I mean, It's also like at a really simplistic level, there's kind of two scenarios that you cater for. You've got a desktop application that you don't want to block the UI thread while you go do things on the background. So that's a great way to do that. The other scenario is like on your server for a web application. Typically you've got, let's just throw the number out there, 1,000 thread pool threads there to service requests. By default, if you're using blocking synchronous code, and let's say there is a web service call that takes 30 seconds to complete, there's 1,000 requests that are going to be blocked for 30 seconds while that web service comes back that literally can't service any other requests at the time. Now, if you turn that into asynchronous, you're technically able to do that because if it's async, it's not going to be blocked by the web service call, and then it'll say, go handle more requests until I'm done, and then come back and finish. So instead of just 1,000 thread pool threads, you've got the ability to service, let's call it 5,000 to 10,000 concurrent requests because you're not actually blocking anything.
And at any given time, 2,000 threads might be sleeping, or not threads sleeping, but the state of some operation is persisted somewhere, waiting while the thread is doing other stuff.
Right.
I don't see much difference besides this and the other one using none. Is that right?
Well, with run, it doesn't know the current thread you're on. So there's parameter there.
With a parent task.
Yeah. Whereas in here,
There's a good blog post online that describes it all.
There's a good blog post all over online.
Why they added in task.run and the reason behind it.
I'd enjoy to have a link to that.
Your goal is
Yeah, I think it'd be a good idea to list that blog post series that you mentioned, and then from what's his name?
Stephen Tobe, T-O-U-B.
That might be good for now that everyone's seen a presentation to go back.
Yeah,
and
there
read
were
the series.
several of them mentioned it in their presentations. If you just start searching around for async and then waiting and stuff, it usually comes up at the top.
Okay.
And there's even
it's
pretty
one of the main
in-depth
methods
white
like blogs.
papers that they've produced that's very helpful.
So,
Well, that about wraps up the presentation.